The phrase, "if it's Boeing, I'm not going," has stuck around for a reason. It reflects real frustrations people have faced with short-haul flights, airplanes that rattle and shake in a way that tests trust, maintenance delays that wreck timetables and strand passengers, and the loud, grating drone of turboprops that makes early morning or late-night flights impossible in many communities. These are the pain points that have defined regional aviation for decades. Now imagine turning that whole model upside down with a plane that doesn't need a runway in the traditional sense, one that can rise straight into the sky and cruise silently across the landscape. That's the backdrop for Elon Musk's 2026 vision, the Tesla super electric plane, an aircraft designed not as a science project, but as a practical machine built to solve those three exact problems while rewriting how short-haul flying feels for everyday travelers. Musk's core philosophy has always been about building things people love, not just things that look futuristic on paper, and the Tesla ePlane follows that mindset. Instead of cramming in features for the sake of headlines, it is positioned as a workhorse that is still desirable, a machine that hits the emotional side of travel while also keeping promises tight and practical. At its core, it is a small airplane with seating for 4 to 12 passengers aimed at community routes up to about 500 miles. Its key advantage isn't just electric power, it's the fact that the turnaround time is slashed to just 15 minutes thanks to modular batteries that can be swapped like building blocks. That means airplanes fly more and weight less, and passengers aren't stranded waiting for lengthy checks. Quiet electric motors reopen airport slots that turboprops lost years ago because of noise limits, which means travelers finally get more flexible schedules. And beneath it all, the electric design strips away hundreds of moving parts that cause hangar headaches, replacing them with factory-level consistency that makes flying more predictable. The Tesla ePlane starts where people notice travel most, the cabin. For many travelers, short-haul flights feel cramped, uncomfortable, and almost hostile to the body. Tesla approaches this differently. The cabin is compact but intelligently arranged, with 1-to-1 or 2-to-1 seating that keeps aisles in the 18 to 20-inch range. That small design detail matters, because it means people can actually move down the aisle without bumping elbows and shoulders. Boarding, too, is simplified. A large, low door paired with a low step height transforms the boarding experience from a small workout into a one-handed task. That same large opening, roughly 50 by 50 inches, is big enough to swallow cargo tubs and medical stretchers that are between 22 and 24 inches wide. This means the same airplane can flip from passengers to cargo to emergency medical service without needing special equipment. Seats rest on quick-release rails, so converting the cabin takes minutes rather than hours. It's a design that treats flexibility as a core value, not an afterthought. Durability is another quiet but critical piece. Short-haul planes fly far more cycles than long-haul jets, which means fatigue and corrosion wear them down quickly. Tesla designs against this by using a sensible mix of corrosion-resistant aluminum for the main structure and lightweight composite panels for fairings. High-stress areas get extra doubler plates, seams are placed where mechanics can easily inspect them, and all recurring inspection points are accessible without ripping out the interior. Even the seats and restraint anchors are tested to dynamic crash standards rather than simple pull tests. In plain English, that means the cabin is proven to protect people's heads and hips in the event of a rough landing. The target service life isn't measured in just a handful of years, it's tens of thousands of flight hours before heavy structural work is needed. Step outside and the design speaks again. The wings are smooth, with clean leading edges and modern wingtip treatments that cut drag and soften the pressure waves people hear on approach. Enclosed landing gear removes the whistling and rumbling that so many turboprops inflict on nearby neighborhoods. Propellers are carefully sized to keep their tips below the high subsonic threshold, avoiding the piercing whines that travel far through the air. Combined with quiet electric motors, these choices allow airports to schedule flights in early mornings and late evenings without the noise complaints that usually shut down regional service. Noise is not just about comfort, it is about legal access to more flight slots, which translates into more reliable schedules. Maintenance is often what kills efficiency in aviation. Tesla flips this problem on its head by making serviceable first the golden rule of its design. Components that get heavy use, motor controllers, inverters, battery management electronics, the environmental system, and core avionics, are treated like line-replaceable units. Each is placed behind dedicated access panels with keyed, color-coded connectors that a two-person crew can swap out in 5 to 10 minutes using standard tools. No seats have to be removed, panels open cleanly, fasteners are standardized across the airframe, QR codes on each unit link to digital manuals and service history. Batteries, too, are modular. Crews can guide, latch, and interlock preconditioned modules safely into place, completing a swap inside that fixed 15-minute turnaround. What this means in practice is an airplane that spends its life flying, not sitting broken in the hangar. Schedules are where the Tesla super electric plane becomes revolutionary. Regional aviation is notorious for delays, cancellations, and broken connections, but this aircraft is designed to make schedules as predictable as trains. Two numbers drive this: a guaranteed 15-minute turnaround and a practical range of up to 500 miles. That combination turns ramp minutes into flight minutes, squeezing more actual flying into each day. On shorter routes, say 250 miles or less, one leg plus taxi plus the 15-minute ground window adds up to about 60 to 90 minutes. That means one airplane can credibly fly 10 to 16 legs per day. Stretch the distance up to 500 miles and the cruise time grows, but the ground routine doesn't change, so operators can still manage 6 to 10 legs per day. The power lies not in setting record numbers but in the fact that the ground rule repeats without surprises. Schedules stop unraveling because delays don't cascade. For travelers, the difference is measured in door-to-door time. Many regional drives today take 3 to 5 hours once traffic and stops are included. A Tesla ePlane hop up to 500 miles compresses that into roughly 1.5 to 2 hours end-to-end, including check-in and transfers. That's because the plane uses small local airports with short taxi paths and minimal queues, and the ground turnaround stays at 15 minutes instead of the long hub waits we're used to. Add to that the thousands of underused community airports in the United States alone, and the potential for fast, convenient regional hops opens wide. The quiet factor is another hidden lever. With cleaner aerodynamics and electric motors, these airplanes can legally fly in early morning and late evening windows that turboprops cannot. More permitted hours mean airlines can schedule flights exactly when passengers want them. That directly improves reliability and raises utilization, creating a virtuous cycle: more flights, more convenience, and steadier on-time performance. Costs, of course, are the biggest driver. The Tesla ePlane saves money at nearly every level. Its direct-drive electric motors eliminate gearboxes, reducing vibration and inspections. In cruise, modern electric motors and inverters run at 90 to 95% efficiency, meaning most of the stored energy becomes thrust rather than waste heat. With 2 to 4 independent motors, one unit can even be shut down without ending the flight, preventing small problems from becoming disasters. The batteries, built as swappable modules, hit a practical target of 360 watt-hours per kilogram, translating into about 600 to 900 kilowatt-hours of total capacity at a manageable weight. That's roughly equivalent to the energy of 6 to 9 long-range Tesla cars. Cycle life matters too. The pack is designed for 1,500 to 2,000 uses, meaning years of daily service before replacement is needed. Cooling systems keep cells in their safe temperature zone while the battery management system protects against charge stress. In practice, this means predictable performance and longevity. During the day, batteries are swapped in minutes so airplanes keep flying. At night, high-power charging replenishes packs in about 36 to 60 minutes when electricity is cheapest. This rhythm, swap by day, charge by night, keeps the economics steady. Energy cost comparisons are dramatic. A Tesla ePlane cruising at 200 to 300 kilowatts consumes about 300 kilowatt-hours per flight hour. At electricity prices of 12 to 18 cents per kilowatt-hour, that's $24 to $54 in direct energy cost per flight hour. A comparable turboprop, burning 50 to 70 gallons of jet at $4.50 a gallon, costs $225 to $315 per hour in fuel alone, before maintenance. Even after accounting for battery wear and routine checks, Tesla projects 15 to 25% lower total hourly costs within the first 2 years of steady service. Now look at route economics. A 10-seat Tesla ePlane flying a 500-mile sector at 85% load carries about 9 paying passengers. Cruise time is roughly 2.5 hours at 200 miles per hour. The electricity bill is about $78, landing fees add $20 to $40, and linearized wear adds $35 to $55. Direct cash cost per flight is roughly $133 to $173. That works out to about $15 to $19 per paying passenger before